Good day, online viewers. My name is Nayz from Marina Academy. Okay, welcome to our online platform. Today we are going to be looking at chemistry, specifically the topic which is the periodic table. Okay, so today we are going to look at the groups, what a periodic table is, what a group is, what a period is. Just and read this the word the periodic table. Okay. So here first let's define what a periodic table. I bet you are able to see the periodic table here. It's not really drawn the way it is supposed to be, but you can still have a script of it. So this is just the way it is. This is the way it appears. Okay. As you can see, it has 8 groups. We are having group 1, group 2, group 3, group 4, group 5, group 6, group 7. Okay. Group 8 actually. This one, let's actually put it as 0 because it's towards the same. Okay. Then with the periods, they've not really been characterized, but this is just that to show to say the period it is what in a horizontal line. Okay. So let's define what a periodic table is. So a periodic table, this is a piece of document that has elements arranged according to their proton number. Okay. So this is a piece of document that has elements arranged according to their proton number. Okay. Then after looking at that, I think the last time that you looked at chemistry, you were able to define an atom, and from there you defined what a proton number is. So I'll just go straight to there. Okay. So we are going to look at a group again. So a group is a vertical column. Okay. So as you can see, this is what it is in a straight line. So meaning it is a what? It is a vertical column. Okay. We got to a period. What is a period? Okay. So a period is a number of shells that are formed, and it is a what? It is in a row form. It is a row, meaning horizontal. Okay. So a period is a number of shells that are formed, and it is a what? A row. Okay. So here, after looking at that with all the explanations that we are going to have, we are going to now put them into their respective groups. Okay. So we are going to put them into their respective groups. Okay. Okay, so here we're having group 1, group 2, group 3, group 4, group 5, group 6, and group 8. 0 is known as group 8. Okay, so from group 1, group 2, and group 3. Oh, these that are on the middle here, I'm leaving them out because they're transition what? Metals. Okay, so these are what on the middle of the periodic what? Periodic table. Okay, so here we're going to look at group 1, group 2, group 3. Group 1, group 2, group 3. These are known as metals. These are what? These are metals. Okay. And metals are going to what? They're going to lose electrons. Okay. So these are metals. These metals are a class of chemical elements which always form positive ions when they react to form what? Compounds. Okay. So they are often shiny solids. Okay. So with that information, I bet you understand what we mean by what? By metals. Now let's look at transition metals. So transition metals are found in the center block of periodic table. They have high densities, high strength, and high melting point. So these are the ones that are actually what you're actually seeing here. Some examples of transition metals are what? It's copper itself. Okay. So we all know, and some of the uses, just to tackle on this one. Some of the uses is the Haber process uses an ion catalyst. Okay. So here, this is what some metals are actually used for, the transition metals. We go to these, which is group 4. Group 4 are known as metalloids. Okay, they are known as metalloids. They are known as metalloids because group 4, it is actually a combination of metals and non-metals. Hence, with anything that has to do with group 4 or anything that has to do with the transfer of electrons, with these, the 2 atoms are going to share the electrons. So those are what? Metalloids. Okay. We are going to look at now group 5, group 6, and group 7. These are non-metals. Okay. So these non-metals are elements which do not have the properties of metals and always form the negative what? Ion when they react to form ionic compound. That is to why when we mix a metal and a non-metal, a metal will be the one to lose to a non-metal for it to balance. So it will share what? Electrons. Okay. Then with group 8, these are what? These are noble gases. Okay, so these are what? These are known as noble gases. Okay. Now we go to this example. Actually, that is there to show us how we can solve for these things that are in the periodic table, the elements that are in the periodic table. Okay, so here with the elements that are in the periodic table that characterized as like something like this, this is how they're actually put. I think you can start by you've all seen what a periodic table is, or you know what a periodic table is. If you have it nearby, you can refer to it. Okay, so here on the periodic table, you are going to have this. Actually, sometimes it can actually be something like this. Then here on top there is the mass number, and here there is the what? That is the proton number. Okay. So here this is the what? This is the element. S is representing the what? The element. Then M it is representing the mass number. The mass number, which is the combination of what? Protons and neutrons put together. Then the proton number is that also represents the what? The electron number, because you all know that proton and electron number are the same. Okay. So here we are actually going to configure it. Okay. So what I mean by configure it, we're supposed to know which group. What enables us to know onto which group when you're given an element, what will enable you to know which group and period it belongs to? It is what? One, the one that's going to enable you to know the period it belongs to, it is going to be the what? The number of shells you're going to have. Then the one that is going to enable you to know the group, it will be the valence. The valence, it is actually the what? These are electrons that are, this is the number or the total number of electrons that are on the last shell, which is the energy level shell. Okay. So here we are going to do this. Here, always what to use when you're dealing with something like this, it is the proton number. With the mass number, you never use it unless otherwise they tell you, maybe they tell you to say subtract, find the neutron number. That's when you use the what? The mass number. I bet you looked at that last time. Okay. So we're going now to what? To configure 17. Okay. So the rule is that when you are drawing an atom, an element of an atom, the first shell, it is supposed to have 2 electrons. Okay. So here you are going to say 2. You say is equals to, okay, just say 2, you put a comma. So from 17, we subtract 2. How many are going to remain? So from 17, when we subtract 2, 15 are going to remain. But on the second shell, you are always supposed to put what? 8 electrons. It is not supposed to be above 8. Henceforth here, 2 you've already put, you are remaining with 15. You are going to subtract 15 minus 8. So here 15 minus 8, okay, we can subtract on that one. Okay, it is going to give us 7, okay. Henceforth here we are going to put what? We are going to put, let's put 8 here. Okay, so we put 8 here. Then you see to say, it is supposed, the configuration is supposed to give you the total number. So here you are going to do 2 plus 8, which is going to give you 10. So meaning you are supposed to subtract 10 minus 17, hence giving you what? 7. Okay, so you are going to say 17 minus 10. 17 minus 10, which is going to give you